Hi guys, you're welcome back to my channel. In this video, I'm taking you through review exercise on functions. We've already gone through part 1 of this, so we are in part 2 of our review exercise on functions. I have a couple of problems for us to go through. Stay glued to your seat, get your calculator, make sure you move as I move. Now, let's go to the first question. Find the domain of, I have my first function, that is f of x is equal to 1 over 2x minus 6. How do I find the domain of this? What's the domain of this? Domain is simply the set of input that makes this function defined. Whenever you see a rational function, to find the domain of a rational function, it's just so simple. Make sure that you take out every term that will make this function undefined. So I'll simply have 1 over 2x minus 6, right? Then I'll have for a rational function which is a over b to be undefined, meaning that b should be equal to 0. But if I want values that will make this function defined, I'll find out for values of b that will be what? Not be equal to 0. Hence, I'll write 2x minus 6 and I'll equate it to 0 to get the term that will make this function what? Undefined. Here, when I solve, I'm going to get 2x is equal to 6. X is equal to 6 out of 2, which is the same as what? 3. Okay. So now x is equal to 3, meaning that my domain is x is such that x is a member of all real numbers where x is not equal to 3. That's all. Number 2, this one, I have f of x is equal to 1 minus x over 1 plus x, right? If I have this function here, I want to find the domain. Please take note, whenever you have a rational function, never look out for the numerator. It's always what? The denominator. So that is where we can get terms to make this function undefined. So then how do we go about this? So to find the set of numbers that make this function undefined, meaning that 1 plus x, which is the denominator, should be equal to what? 0, right? Hence x should be equal to negative 1. So negative 1 is the number or is the input that will make this function undefined. So for me to write the domain, I'll say x is such that x is a member of all real numbers where x is not equal to negative 1, right? Yeah. Number 3, s cubed. So I'm done with this. S cubed minus 2x all over x multiplying negative x minus 6. As well, you don't consider what? The numerator. Let's focus on the denominator. So negative x minus 6 is equal to 0. To solve this, x will be either 0 or here when you solve this, negative x minus 6 equals 0, you are going to get x to be equal to negative 6, right? So meaning s is either 0 or s is either negative 6. These two values will make our function undefined. Therefore, our domain is x is such that x is a member of all real numbers where x is not equal to 0 or 6. That's all. Question 4. I have 3x minus 1 minus 1 over 2x minus 6. When you have this is an algebraic function. Just take good care of this side, that's all. If you try simplifying before solving, you still have your denominator to be this alone. Therefore, there is no point in simplifying. So here is a set of what? All real numbers, right? Where x is not equal to 3, as we did here. Right? Now let's go to question 5. For question 5, x over 1 minus 2x plus x squared. So now you have a quadratic as our denominator. So 1 minus 2x plus x squared to be equal to 0. What are the set of values that will satisfy this quadratic equation? You point it on your calculator. So you have 1, you have negative 2, then you have 1. So when x is 1, right? So the root of this equation is 1, 1. Okay. So when x is 1, therefore x is such that x is a member of all real numbers where x is not equal to 1. Finally, 6, x squared minus 2x over x minus 3, 1 minus x squared, right? So I have x minus 3, 1 minus x squared. A set of what? Values here that will make our function undefined, or that will satisfy this. I'm simply going to have x minus 3 equals 0, giving me x is equal to 3. Then I'll also take this 1 minus x squared is equal to 0. Therefore, x squared will be equal to 1, and x is equal to plus or minus 1. Therefore, the values of x is either x is equal to -1, +1, then 3. So x is such that x is a member of all real numbers where x is not equal to -1, +1, 3. And that gives us our domain of the function. And that is all for question 1. Let's go to question 2. So for question 2, let's see. Okay, so now let's move to question 2. For question 2, it says find the domain of number 1. This is a set of functions, but this time around they are transcendental function. F of x is equal to natural log of what? X. Okay. For a transcendental function, these are functions which are not algebraic. So we have logarithmic functions, we have trigonometric function, exponential functions. Then we have um, hyperbolic functions as well. Now let's see what is the domain of this function. We are just looking out for values that will make this function undefined, then we take them out. Natural log of 0 doesn't exist. Okay, natural log of 0 doesn't exist. Natural log of negative numbers doesn't also exist. Therefore, our domain is x is such that x is a member of what? All real numbers, right? Where x is greater than what? 0. That's all. Because when x is greater than 0, I'll make sure I'll get what? Elements which are positive alone without the 0 itself, right? Or we can also say that r plus, that is a set of all positive real numbers, is the input. Let's see the second one. F of x is equal to log to the base 5 of 1 minus 3x. Okay, log to the base 5 of 1 minus 3x. So to do this, you also need to consider here. The same rule applies. Input here cannot be 0, can also be less than 0. So I'll have 1 minus 3x to be what? Greater than what? 0. Therefore, simplifying, I'll have 1 is greater than 3x, and therefore x is less than what? 1 over 3, right? Therefore, x is such that x is a member of all real numbers where x is less than what? 1 over 3. Okay. So once I have this, I'm done with the second part. Now let's see. So I've done this, I've done this. Now let's go to the third one. The third one is e to the power 1 over x plus 1 minus x is equal to f of x. Okay. So once I have this, let's see. This is an exponential function, and the power of the exponential function is a rational function, and specifically it's an algebraic function because I have this rational function here in addition to this monomial. So how do I get the domain? Right. So now, for me to get the domain of this function, for exponential function, is there values to make an exponential function undefined? No. Exponential function takes in positive, negative, and even 0. So it's a set of all real numbers that will satisfy. But now, the argument of this exponential function is also a rational function. So meaning that we need to take care of that. We can't put in any x because once the power is undefined, the whole thing becomes undefined. So therefore, our interest is at the 1 over x plus 1 minus x. Here you know that x cannot be what? -1, right? From here, x can be -1. Therefore, the domain is x is such that x is a member of all real numbers where x is not equal to -1. That's all. Now let's see. We are moving to the fourth one, right? So I move to the fourth one. F of x is equal to e to the power x squared minus 1 plus natural log of absolute of x plus 1. Once I have this function here, once I have this function here, this side is an exponential function, this side is a logarithmic function. For the exponential side, I said it takes in everything except that you look out for terms that will make our function undefined. But for x squared minus 1, it's a polynomial function and there's also no value that will make it undefined. Hence, this side is free. Now we come to this side. For this side too, we know that a natural log or logarithmic function doesn't take in negative numbers. But sake of this absolute sign here, we can accept negative numbers because it will become positive. For that reason, negative numbers are accepted, positive numbers are accepted. But let's see 0. Is 0 accepted? Yes. Because once here is 0, when you add, you're going to get natural log of 1. Therefore, this function is, the domain of this function is simply x is such that x is a member of all real numbers. That's all. That's all. Now let's move to the final part of our review exercises. Okay, so third, right. Determine whether the functions below are even, odd, or neither. Let's see the first one. F of x is equal to this one, e to the power x squared minus 1 plus natural log of absolute of x plus 1. Remember that for an even function, f of negative x is equal to f of x. That is for even. For odd, f of negative x is equal to negative f of x. Then neither is, you see that thing. Now let's see. So the only thing you have to do is find f of negative x. That's all. F of negative x. What is f of negative x? F of negative x is putting negative wherever you see x. So I'm going to have e to the power negative x all squared minus 1 plus ln absolute of negative x plus 1. Remember here it's squared, so I'll have e to the power x squared minus 1 plus natural log of absolute will still be what? Positive x, right? Plus 1. You can see that this is the same as the original, therefore it's an even function. Even. Now let's see the second part, which is this. So the second is saying that f of x is equal to x squared minus 2 over x multiplying 1 minus x squared, right? So having this, to solve this problem, you only have to put in your f of negative x. What is that? I'm going to have negative x all squared minus 2 over negative x multiplying 1 minus negative x all squared, right? Like that. I keep on simplifying. This becomes x squared minus 2 once again over here. I'm going to get negative x 1 minus x squared. But now we can see something here. You realize that initially I had this h to be what? Positive, but now it's negative. Okay, once you have a negative expression here, it's affecting the whole thing. Okay, it's affecting the whole thing. So meaning that we are getting, I can factorize negative out here so that I'll get let's say x squared minus 2 all over negative 1 x, then probably when I'm to expand this, I'm going to have let's say let's expand here. So here, let's try expanding here. If I'm expanding this side, I'm supposed to get something like x minus x cubed, right? So if I put in negative, I'm going to get here negative x, then here will be what? Plus x to the power 3. That's all. So you ask yourself, this is negative of what? This, right? This side is negative of this. But look at the numerator. The numerator remains unchanged. The numerator remains unchanged. So can we say that our f of negative x is entirely negative of f of x? That's the problem here. Can we say that? Because if you are to take negative out here, you are going to get 2 minus s squared. That will be the negative side of this. Therefore, this is neither. 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 Now let's see. Question 3. F of x is equal to s squared sine x. S squared sine x. So we put f of negative x, and that will give us negative x all squared sine negative x. S squared becomes s squared because negative squared, yeah. Sine is an odd function, so it comes out as negative, then sine x. Therefore, we are getting negative s squared sine x, which is exactly negative of what? The initial. Therefore, it's even function. Oh, sorry, odd function. It's an odd function. Odd. Let's go to the fourth one. So for the fourth one, I'm having this here. F of x is equal to x root of absolute of x minus 1, right? Once you have this expression here, I'll put in my f of negative x, and that will give me negative x here, root of absolute of negative x minus 1. This becomes negative x. Know that absolute root of that becomes still what? X, right? Absolute of x, the same thing, that doesn't change. Then you have negative here. So we simply multiply negative by it, and this one too is a perfect odd function. It's because it was what? X this, and I multiply it by negative, and it's negative this, right? Negative that. That is it. Now let's see the fifth one. Okay, fifth one. So for the fifth one, I'm having f of x is equal to natural log of what? Tan of x minus e to the power absolute x. So first of all, you consider the natural log, you consider the tan, consider the exponential function. You only have to find f of negative x. So f of negative x, natural log of tan negative x minus e to the power absolute of negative x, right? Like this. So I have natural log of, yes, so whenever you have tan of negative number, what do we get? So let's say tan of negative 50, you get negative, right? So you get negative tan x. Here is the same thing, e to the power negative x. Sorry, it becomes positive. It's an absolute, so it's the same thing. So what are we still getting? Now, this was initial what I had. So this is also neither because it's not affecting it entirely. Okay, it's only the tan which is changing. Only one part of it is changing. So this is neither, 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 neither. So this is neither, neither. Then finally the sixth one, this one, f of x is equal to x minus 1. I find my f of negative x, and that is negative x minus 1. This and this. This is the same as negative open bracket x plus 1. This and this are not equal because this s minus 1, s plus 1. So the negative here. So this is also neither. Thank you for joining me in this section. Please don't forget to subscribe, like, and share.